next up is Sabine. We went from the 4th floor of this building to 2.5 hours away, Purdue. So from Haley, 3 hours, at least 5 hours.
Yeah, one more.
100 hours by
Took me 3 to get.
Sabine, thank you.
Okay. I'm going to just carry that. Can you hear me? Mm-hmm. Okay, so, and my tag says Northwestern, wishful thinking.
Yay.
I was visiting, so that's, but I didn't do this, so I'm just going to carry it. First, I would like to thank the organizers, Nosh, still here, no, Brian, they all left, and also the others. Other speakers for all these insightful, inspirational talks yesterday and also this morning. When Nash asked me to speak, I was thinking, how can I make a contribution to AI and social networks? Because I do a lot of work on networks, network analytics, mining large big data set, but that's not necessarily how you would think of AI in social networks as an active agent. But then I have some ongoing work which is about AI in human teaming and group AI in teams and groups where AI is an active agent. And there we use neural networks. So I think with the neural network, I cover the network and look into teaming in groups, not necessarily looking into network techniques and network theories. And I think it relates to what we've seen yesterday. So if you talk about human AI teams or groups where AI plays a role, the question is, how do we make sure that we create a symbiotic relationship, that they support each other? It was also a key topic yesterday during the talk. So what I want to do, briefly a little bit about the reason why I'm focusing on social intelligence, and then presenting 2 ongoing studies, and if there's time, also an outlook on some of the work we're doing at Purdue at my center related to cognitive engineering and neurotech for AI-enabled shared intelligence. That relates a lot to the talk yesterday from Paul, and maybe there's time for it. So let me see how it goes. You have to just keep track of my time because I didn't really practice. So you said you finished last week. I think we finished yesterday. I'm not done.
Even fresher.
So, yeah. Okay, so I run a research center out of Purdue. And we're interdisciplinary. I'm interdisciplinary trained, and we're just excited about digital technologies because they allow new ways of bringing together human and artificial intelligence. And, artificial intelligence has been a term that's been around for a long time. Simon has already coined it. So, even if you have a DevOps system, an open source software, which is basically testing whether you can integrate software, you have some machine intelligence. We've actually been dealing for this for a long, long time. Well, I think what's interesting nowadays is that we have machine learning and we have, intelligence that learns from data in real world, and the goal is really to increase also the intelligence of the systems. I got really excited about UAVs the last years, and the reason is a little bit maybe also personal background. My first kind of job was in aviation, come from a pilot family, and I just want to mention because we got also some research fellowship there. I've just hired a PhD, and we have another postdoctoral fellowship related to human autonomy teaming in the UAV context, where they're increasingly using actually machine learning on board to make the system more autonomous and not just automated, because otherwise it would be rule-based. Well, how do I use AI machine learning? On one hand, looking, or my team, I would say, as I have to, we really work as a team to look at, complex data structures, or actually where AI becomes something that you study using a very traditional social science methods, experimental designs in the lab, or etc. Today, I want to really look into AI in human teams and groups. And I want to talk about social intelligence. Maybe not necessarily a scientifically established term, but if you read some recent articles talk about, the AI needs to have this ability to be accurate, because if it's not in its prediction, it needs to be, be able to make predictions that are useful for humans. At the same time, they should also have some social intelligence, should have the ability to show expressions, emotion. We talked about this yesterday. Maybe be aware of human biases, etc. So that's kind of another dimension of intelligence that's discussed right now in research and practice. So, well, one might think that goes together, but I believe that there are right now two separate discussions going on, and they have an impact on how humans and AI team up, and also the ability to actually form a symbiotic relationship between AI and humans. So the first study is about that, and the first study is about empathy in conversational AI in one-to-one human teams. So it's actually a study that I started here with Daniel. Daniel here is at Northwestern, and he also is working with Innovation Labs. Innovation Lab is also involved from computer science, where there's a huge discussion about AI and law and CS, and he's been very active on that. And the motivation was there, well, we have an increasing uptake of bots in areas where it was very important in the past to have an expert, delivering the service. Like we talk about healthcare, a doctor, or we talk about law and legal experts that give advice. But nowadays we have these chatbots being developed, and it's actually this research was motivated practically because we got exposed to Reintervention, which is an organization, a law organization here in Chicago that has built that bot, and Rennie we call it. And there's some concerns, in particular among the professions of lawyers, to say such bots can never substitute a lawyer, because a bot can never substitute a lawyer giving advice, because we built that interpersonal relationship, and it's impossible that a bot can do that. It's not necessarily about the knowledge, because they agree, yes, there might be a way to to really build an expert system to do that. So, well, there are tools out there that now, they can use, and they've built their bots, and then they try to use now advancement in generative AI. We talked about this a little. There's transformers, pre-trained transformers that are generative. ChatGPT, GPT-3 is out there. Use advanced natural language processing models. BERT is standard, everybody knows it. And they've tried to use that to really build better conversation and ensure that the bot is maybe also more aware of what the human feels, and not just necessarily what advice it should give. Maybe sometimes I even say he should give. Well, standard is that many bots still rely on rule-based systems. Rule-based systems that are built by experts, in particular in this case, a law. There's the law, and so the access to training data would be there in terms of legal documents, but actually how legal cases are solved is still kind of really hidden knowledge. So training, a bot on a large data set is hard. So there's going to be these rules, and then use generative AI for natural language generation and so on top of that then rely on neural networks, active learning, transformer learning, etc. But we were planning to do that and have a lot of techies, in my lab. We said, let's try to see how we can use this generative AI and to work with intervention to make it better. But then throughout the conversation, we thought there's fundamentally something related to be studied first in a more traditional way before we do something like this. And that is focusing on empathy, in particular effective empathy, in the way the bot gives advice, in the way the bot, talks to the human. And yes, there's a lot of discussion in the social science waves about empathy, what it is, affective and cognitive. And we know there's an affective and a cognitive component. And I'm going to focus only on the affective part, which is basically, kind of an automatic response. And there's, in linguistic, actually theory that has particular focus, not necessarily underlying reasons why people are empathic or not, even, so there's individual differences, can be learned, is situation specific and so on, but actually how it is expressed in the conversation style, how we speak. And, if I take the literature and how on the one hand, there's a discussion. We know that it matters, and there's a bit of a hiccup if it is moderated or interacting with emotion, particularly anger. And anger, the reason why we focus on anger, because in a legal setting, actually anger is something that's very relevant, comes out of literature. And then there's this increasing uptake now, discussion also in the AI literature, that empathy matters, and they try to build some empathy, and they use some, smart algorithm to do so. And apparently it has a positive effect because they're training on the different emotional step. But what's really unclear is how does the actual display of empathy based on lexical and syntactic elements affect the relationship between a human and AI. And when I say syntactic and syntactic elements or rhetoric elements, I specifically focus on various simple changes in the way you talk, like third person or first person, etc. So we kind of developed a kind of a theoretical model. We argue that effective empathy, the way it's displayed through language, has a positive effect on the relationship, and it may also be moderated by anger, but positively, because if you think about attention control, it basically allows you to, if you have some empathy in the language, it allows you to better cope with your anger at a particular moment. Well, so based on that kind of theory, you can actually think about rules on how you talk. And here's just the comparison between non-empathy and empathy. And the one in terms of the person, for example, you say this problem can be solved rather than we can solve this problem. You say the deficit rather than your deficit. Small little changes like this. Or you use past tense in a no empathy, or you use present tense. You use exclamations. You just say continue, or let's see this invitational rhetoric argument. Acknowledgement, small little things that are discussed in this original theory of linguistics. Actually, there's some Japanese scholars that have done a lot of work on that, Italian scholars on that. So based on that, actually, work with intervention and change the bot and the cognitive abilities. We basically hold that constant. We don't change that. We use intervention from that company and only change the way empathy is displayed in language and change the rule system. Here's an example. Based on the information provided, it took the landlord more than 30 days since the tenant moved out. The tenant was supposed to have, and then based on what we know, it took your landlord, you should have received. Simple changes like this. Well, we were kind of not sure whether this is going to have an impact. But then we're motivated by that theory and reading these articles. We go, let's try. And so we then sampled people into 3 different treatment groups. We built our own Firebase app where we embedded those bot models. Built also another control, which is an FAQ site, which is actually we took in an existing site that's used there, and then basically used the Northwestern Sonic pool. People that are older than 18 years, fluent in English, etc., and sampled people in there. Yeah, they went through. Then once they were in that treatment group, we also induced anger, followed also existing, they got a scenario where they were really then, we made them angry about legal services. You might question whether this is enough. We did a lot of p-testing on that and then measured cognitive effort, helpfulness, and trustworthiness with surveys, but also we looked at some behavioral scales and comprehension, interrupting. It's kind of workflow. I think I don't have time to go through all that. How much more do I have?
50.
Okay. Yeah, this is kind of the scenario. I think I'm just going to click through. So here are some preliminary results that we find after running some factor, ANOVAs, but also regression DLM models. Empathy apparently reduces the cognitive effort and increases the helpfulness. There is some, main effects from the ANOVAs that you find even on the interaction and the action. If you look at the main effect, if you look at the simple effects, what is really interesting and pretty strong is with the trustworthiness. You see if there's no anger, empathy really increases trustworthiness. But if there's anger, it's actually low. So it doesn't really have that much of an effect. So yeah, we can support the hypothesis that empathy expressed in language matters. And also when we put in a bunch of controls in the regression, it doesn't change anything. The effects are still there. So there seems to be an effect that if you have empathy in a language, that actually increases human AI teaming relationship. But anger actually might really, throw that away. Well, there's then contributions of research on empathy, and also in contribution literature, but also has practical implications. So you have to think about how you design your bot. And when we talked a lot about the engineers that built that bot, they were just throwing things they were thinking of. How do I design it? Yeah, I just do it the way I think I should write. But it actually matters how you write. And even if the rule is great, and if, the legal suggestion made is right, it might throw off the person. So yeah, how are we taking that further? Yeah, we definitely want to now also work on generative AIs, but I think we're going to actually consider that as we are training some neural networks on that, and consider that when we try to predict an emotional state, and also when we try to predict then an empathy response. Because it apparently matters how you structure from a syntax point or from a rhetoric point of view, your response before you think a higher level kind of empathy constructs or emotions. Well, that's the second study. I don't even know whether I'm going to get through this because I didn't practice, but let's see. The other topic is about nudging humans into collective action through AI-enabled social norms, a deep reinforcement learning model. That's something coming out of research together with Shatayu. It's one of my former students. He's now at Facebook. By the way, if you use Facebook and you're single and you're doing all that partner matching, he is actually working on the matchmaking algorithm behind it. Maybe I'm not allowed to say that. But yes, he might get angry at me. So, but we've been working as we still work together on collective action. You might know all about that, the tragedy of the commons, because everybody tries to think individually, you optimize your individual reward, even though you would be better off if you're actually, contributing to the commons, the collective good. And overfishing is used as a typical example. I mean, we know about energy conservation, climate change is one of these examples out there that we are aware of nowadays, where collective action is really having an impact. Well, in research, we use collective action games to study that, and there's been a tremendous amount of work on that. And they consider that we actually fall into 4 categories. We have people that are cooperative. We have people that are free riders that never cooperate. And then there are conditionally cooperative people that are sensitive to their own, reward, so to speak, what they were doing in that particular time, and also the behavior of the group. So if the group is going up, they might also do more. If the group is going down, they do less. And here is just an example of a game. If you have at the end of the game, that's 25 rounds, then you have a certain number of points. In a collective action game, you would then equally split that based on a factor that is increased. So it's just modeled off of some of those games, our research. But the overall problem always is in that research is like, how do I address these conditionally cooperative people that stop contributing, because we do in the beginning often have that curve going down. Now, what do I do? How do I design things? Should I pay them more? Should I punish them? And there's this concept of social norms and descriptive norms in particular that has shown to be actually effective. And the social norm, not just something that's discussed there in behavioral economics. You change the architecture around the human by showing them what others are doing. And even though there's research that has built reinforcement learning models to model the conditionally cooperative behaviors, there isn't much on the role of AI in that. So you're throwing an AI agent. Well, and that's where our research makes a contribution. Let me click through. Those are just examples. There's increasing work right now that shows, if you basically have an AI agent that's a real agent in these collective action games, people might actually adhere to social norms more. There's a study done in hospitals where they put up a robot and it showed you how much the robot basically saved in his energy, the way he acted, and then just showed that, and apparently that had an effect. Yeah, and that kind of triggered our thinking. And then we built an RL agent, a traditional one that's a human-like agent. I don't think I have time to go through that in detail, the logic. That's kind of is rule-based still. It uses ideas that people from the Carnegie Mellon School know about aspiration and adapt that. Here's the formula for that. But what we then did, we built a deep RL agent, which is basically more intelligence, and that's what I consider, is an intelligent AI that we put into this collective action game that tries to optimize the group's goal. Basically creating social norm not just through his own behavior. Deep RL basically all depends on for elements. You have a state space, an action space, a decision space. You have a reward. You don't have a rule, but you're trying just to learn the best policy. At least that's an algorithm we chose. We used one of the recent algorithms. Policy optimization, without going into detail. It's different from Q-learning in case you know that Q-learning is model-free. You don't necessarily have a policy of characteristic changes. We use that. And it's more stable, and we adapted that. But we trained it on two things: to optimize the outcome in terms of the sum contributions made, or the number of conditionally cooperative people, those that basically contribute more. And so that's kind of the theoretical model and behind. So we used 4 to 3 are real people, and in the end that follow a reinforcement learning model, and it has been empirically validated, and we validate ourselves. And we put a bot in here that has either the goal to increase the number of cooperators or increase the total sum. 2 different reward functions. So kind of control, and then we had 2 treatment conditions. Validated the results, so empirically validated our baseline, our human agents, and they really follow empirical patterns. And then this is the treatment. It's kind of the baseline model with only the human agent that are based on RNL. And then we have the 2 different AI agents that we trained, the proportional and the sum agent, as we call them. And I don't know whether you see that, but you see a subtle shift of the distribution. You have more people on the higher end. And this is now for the median. If you then look at that, you see that, the AI agent follows a very different behavior in terms of contribution over time. Here, that line looks pretty staged. That's kind of the mean contribution of the humans. And you might think that might not have big of a change, but if you compare that to the baseline, that's actually a 20% increase or 26% increase depending on the AI agent that you trained in terms of contribution at the end. So, and if you look at the median even more, that shows us that AI can actually have an impact, apparently, on shaping human behaviors indirectly. Well, contributes to existing work. I don't have time to go through this. Because we show that AI can actually play a role in shaping, social norms indirectly, kind of an invisible hand on top, and then create social norms. Well, there are limitations. We didn't put this in a real condition yet. We basically built simulations here based on empirical data validated, but that's actually what we're going to do next. And we did not kind of give that a physical embodied structure. We don't work on robots here. But the next thing is we are going to go back and play these games which we've done before in the lab and online. And we also work with housing communities where we have energy conservation and using that bot. And that's the next step. And then hopefully also thinking about network structures, because some of the early work has also looked into different information flows among agents. Well, that's it. I think I have 5 minutes.
You still have 5 minutes to present if you'd like.
Yeah? I can either now go to the discussion or present a little bit on the project with UAVs that we're doing. I should continue?
Yes.
Okay. Yeah, so just concluding that those are the next steps that we're moving on with that. And I hopefully can share some results as this is moving forward. One last thing that my group is doing is it's related to what Paul has been talking about yesterday. You know, how can I use physiological data and neurotech, as I call it, or brain-human interfaces that collect data about the human in real time to shape human autonomy, interaction and relationship. And that's together with colleagues in aeronautical engineering, together with people also in cognitive science or a computer science background, and also neuroscientists. Some of these ideas that you see here also come from discussion with Moran. It's early stage, but some of that is actually building upon work that's already done in cognitive engineering at our work. So kind of the vision here is to say that in the future, if you think about UAVs flying around there, you basically have the ability, through the smartness of the things we wear, interact with the UAV in a way that you can create shared intelligence models that consider the state of the human in real time, and also make use of the increased intelligence of the UAV. And how would that work if you don't see that UAV because it's flying around there? Well, we use also, digital interfaces. And today, the way what we call them operators, remote operators, interact with the UAV is mostly still kind of, text-based, touch-based. We have a classical way of interacting. But there's new ways of now creating interactions. It's basically through haptic, vibrations, etc. And with that, you can make use of our maybe more holistic sense-making when it comes to a very critical situation, when there is a potential need for bringing in a human in the loop. What do we need there? We need to also incorporate, the existing work of control theory, which is very important, and connect that with ideas of AI. What's important for that? So we've been building, and it's kind of recent, a new operations center, as we call that, where you have people that operate these drones, where all these sensors, these new wearables, and with that, you can then collect data. And we started to collect data and build models on that. And then the goal would also be to find new ways to design sensory additions where you can basically be informed about where the UAV is by feeling it on your back, because you have a map produced on the back, and you can sense the distance of the UAV and how far it is away. Well, there's already been some work done at our group, and in particular by INSEAD, which is a colleague of mine, by using haptic or very tactical responses and trained an inverse reinforcement learning model, and with that having shared control, where you have control structures where the actual UAV knows whether the human is right now an expert or not, based on its actual behavior and its satisfying behavior in the past. And that can then be used to decide whether and how it should hand over control. And now the goal would be to consider also more higher level decision making related to that. I'll end here. I think, just to conclude, I think we need to think about social intelligence as we think about cognitive intelligence and consider them in the loop. We also need to bring in the human in the loop constantly as we're thinking about optimizing human-AI relationships. Thank you.
Round of applause for Sabine, I think you just showed us our future. Questions?
Yep.
I'm not allowed to answer questions. Yeah.
I remember an old joke. What does it take to succeed in television? Mm-hmm. The answer is integrity. If you can fake it, you've got it made. And I'm worried about an evil person who's sitting in this room and coming up with lots of ideas how to build more effective evil bots. Have you considered that this whole thing, how to be more effective, can be used also for evil purposes?
There's always a bad side. Yeah, misinformation is out there. And I agree with that. That's a concern. That is a concern. Yes, I agree. Have I thought about this? There is a lot of discussion, AI and fairness, etc. Right? So how do we address that? That has to be considered, I would argue, as we're building these intelligence models as well. And that's where we, I guess, as scholars ourselves, have to have a responsibility in making sure it's a norm, we should adhere to. But also there is, regulatory issues going on. The European Commission has just, issued, policies for AI design. There's a lot going on. Even NAST and NIST, etc., as a standardization organization, also releases, standards for that. So it's a big discussion. My colleagues are involved in some of these discussions. I'm not directly, but yes, it's an important topic, I agree.
I mean, I'm worried about the economic incentive. What is the economic incentive to have more effective rental help chatbots or more effective spammers? What's a bigger market?
I hear, coming back to the law example and having a bot for law services. Actually, I think there's a positive argument because many people cannot afford to pay a lawyer. But if you have a bot that gives you actually access to law and information you actually benefit from it. And that's, I think, where it's more about making changes in the legal profession, how they think about it, and make sure that they are able to hire people with skills to do that so that more people have access.
No, I'm not doubting that there is a lot of room to use good. I'm looking at the market, what the economic incentives are.
Yeah, I'm asking the economists.
And I just see the economic incentives are much more on the negative side than on the positive side, I'm afraid.
I guess it's a question to bring back to others, right? I believe in the good of human people, right? And that's why I think there are the positive elements, and you should also try to find algorithms that are good, right? And whether you can prevent others to build bad ones, that's an important question that relates to regulation, policy making, etc.
Thank you.
And if you are an economist, please share your answer with us. I'd love to hear that.
This is really exciting work, and I'm curious about how you measure empathy expression and the changes between the original text and then the kind of empathy-enhanced text in the medical and legal examples. Like, how do you know that it's more empathetic, or what were the ways that you measured it was so?
Oh, right now it was a treatment we designed, so to speak, right? So we basically, went through the whole text as a team. We didn't train anything. We had a rule-based system. We basically, created that from theory and went through. And then I showed basically the rules that we applied and made those changes, right? And then ran an experiment. How would I now do that as I'm moving forward? I would basically, have to train, algorithm based on labels, human labels. You need to have some labels first at this point and consider that. I mean, there's also out there, I mean, I could give you libraries out there, you know, that you might know all of those. But if you look at those libraries that don't consider the syntactic and so on elements, they basically have higher level labels. So I didn't find that very useful when we looked at that and thinking of training actually model, because it's just, you know, these very high level construct that they use to label that. You might know the existing algorithms and the data set. I could share that as well afterwards, because that's something we're thinking of using first. And then I realized that doesn't really help me to get to that issue of, you know, simple changes. And it was really when we just looked at what they put in their bot. And then I was like, why did you write it like, you know, in a very colloquial sense? I would be thrown off. Yeah, so this is how you would do it.
No, I like that. And I think there's like interesting research problems in how we disentangle empathy versus respect, kindfulness, non-dominance, all those kind of things. Yeah. And then there's the subjectivities that get involved here too.
So there's also this huge research on anthropomorphism. It's like, oh, you make that more similar, right? Just in terms of language. Again, very high level, but it doesn't go to the underlying reasons why. So basically, that's why I ran a controlled experiment to explain why. And it comes actually down to simple things: first person, third person, to invitational rhetoric or not. Let's see, or say, you know, the landlord, or you, right? And so these simple things apparently matter. And I think we need more computational linguistics to come to the discourse and help us to improve these kind of models that are now labeled at a very high level through MTurk or some other things. And these data sets are then used by a practitioner out there, and they're used in the packages.
I have a question about, I noticed that in some of your examples that you were using the word rhetoric.
Yeah.
And I know colleagues who use the word rhetoric a lot. Aristotle defined it as a counterpart of dialectic, but I've never heard computer scientists embed it into their work. I'm just curious what it is you're using as rhetoric in the examples that you have here.
Give you just an example of a rule I can throw back. Right, can I see that? Oops. Here, so, you know, simulating dialogue that you, instead of saying continue, you would say, let us see, you know, which is considered rhetoric. Sorry, my accent. You know, just the way you express, for example, it's an invitational, you know, statement you make.
I see.
Yeah. So this here are the rules. Basically, come from some of these theories on you know, syntax and rhetoric and how you design empathy in an effective way.
I see. Okay. Great.
Does it answer?
That's not the way I'm used to hearing it defined, but it's not. It's a legitimate way to.
So that's basically based on the linguistic theories that are not computational.
I'm sorry?
Based on linguistic theories that are not computational, come up from computational scholars, but really just linguistic arguments.
Okay.
Any more?
Oh my God.
I'm not an economist, but I'm a lawyer, so I'm also very interested in the legal study. I'm always wondering, when you say social intelligence, how do you distinguish that from emotional intelligence?
It is not, it's just subsuming, so to speak, like I would say, like it is related to that, you know, but emotions are not everything when it comes to social aspects, yes.
Sorry, Marilyn, we got two before you, and then we'll get to you.
Thank you, Sabine. That was really interesting. And it's related to a DARPA program that Anita and I are working on artificial social intelligence. So I'll share that with you. But my question is, how did you induce anger in your participants in a way that was acceptable to the IRB?
That's a good question. So I can show you the scenario again. We basically, you know, made the people very angry about their landlord, right? And because of the money he keeps, and in general how much, because it's actually true that many people actually lose money because the land they're not getting, they're not getting it back because they behave differently, but they don't go to your lawyer because they don't know that they can actually get something. So we basically created that and that scenario. Yeah, we did not use, there's other ways of doing that, sound, etc. It's really text-based. Yeah. Okay. Thanks.
Yes, and to get, I think what Peter was pointing to, in a transdisciplinary, interdisciplinary setting that we are right now, for communication scholars, rhetoric is something very specific. So I think this kind of comes back to kind of the issue that came up earlier with nesting. And so I think when we hear rhetoric, we associate that, like, things that fall under rhetoric for us are things like the debate team, and or looking very much at, how arguments are constructed. And so that has a very specific meaning, right? And so this is all about us learning about different ways these terms are employed. And of course, I see that you have a lot of background in the literature. One thing I would encourage you to, and this may have been done already because obviously not all your literature is up there, but there is a lot on communication and empathy. And some of this shows up in the psychological literature, right? So communication, right, okay. And psychology, kind of, but...
I'm aware of this, like with the nested, it's the same thing. You know? And it's the same problem there, right?
Right.
So we basically really literally went into the work on an expression of empathy in text and language, and they're using their concepts.
Okay. Yeah. And so I think in the text as well, in the language, but I think also since we're getting into the chatbot realm, we're talking about what we consider conversational
practice, yeah?
Yes. Okay. And so that's where I was just kind of, because I was looking at some of the references, and obviously you can't have them all up there. And so that would be a generative area, but it sounds like you've got it covered. So thank you. Thank you for.
There are a lot more,
of course.
Right?
Yes. Okay. Thank you. Yeah.
Okay, we're going to take one last question over here, and while you're answering that last question, Sabine, I'm going to encourage you to come to the front while you come up and set up. So, do you mind answering?
Yeah, so right over here. So I'm curious with the applications for law and mental health. Those I'm starting to see like a theme for other presentations yesterday, but I'm thinking of our music education last night where the musicians mentioned that, they don't like when a conductor, is very mean or harsh and that kind of thing. So I'm curious, what could you see being responses to non-empathetic AI in those like trust-based kind of professions? So it's not quite trust repair, but if I'm dealing with like a law chatbot that is unsympathetic or unempathetic, is that a space where we could see people deciding to opt for the more expensive human, or are you thinking that there could be other kinds of potential opportunities for competitors to differentiate in the market based on how emotionally comforting they could be? I'm just curious how you could view that.
You need to have a really good bot that's, not saying stupid things in terms of, for example, the legal advice, right? But you can definitely differentiate in the way it considers the human emotion and also how it expresses language, emotions, or in particular in this case, affective empathy. I'm convinced that it matters a lot, and that we need a lot more work to do that. And this is basically just the start, like looking into a small little thing of effective empathy. There's more things, that's what we want to also do, right? But I think you need to consider both. Everybody talks about they're not predictive, they're making the wrong predictions, our algorithms are not good enough. At the same time, we also need to find better ways to design the software, emotional, just if it's a self-fabricated intelligence of our agents as well, that also have an impact.
Thank you.
Okay?
Thank you. Let us